All right, last video I'm recording in this stretch, so let's have some fun. We're talking more about Barbie. Don't worry, next time we're going to talk about phones. So here's the data from one of the groups. They forgot to record how much the distance of 5 was. So we're going to try to see if we can figure that out and help them out. So we're going to go to our calculators and do the scatter plot from there. So if you open up your calculator, we will. Let me clear this off. So again, remember to enter lists so that you can do a stat plot on this. We're going to hit edit. We're going to hit stat first, and then we're going to go to edit number 1. And then we're going to go ahead and type all of that in. So I've got 0 and 1 and 2. Now we're going to skip number 5 because obviously we don't have data that matches with that. And then over here, 25, 32, 41, 49, 55, 69, and 78. Oops, went too fast. $25, 32, 41, 49, 55. See, I make mistakes too. Now, the way that you end up getting this so you can see two things is that we're going to come up with a line, and we're going to come up with what the regression is, just so you know. So what we're going to do is, to do that, we're going to go to Stat. We're going to go over to Calc. And we've already used this for one variable stats. Two variable stats gives you the same data, but with both variables separated. But if you come down here, there's something called linear regression. And so we're going to run that. So we got list 1 and list 2, because those are the two things that we're going to go through. Linear being we're trying to make a line out of this. Regression for how close to the line we're getting. And then we're going to go down and hit calculate. And there we go. So our equation here then turns out to be, now notice here, the first number here, A is right here, B is up over here. Some people usually at this point ask, what about the other one, Mr. Hayes? Because if I go over here to calc, there's also this one down here, number 8. And it's the exact same thing. Just notice it's set up differently, okay? So if we come back over here, our equation is going to end up being, and we put a little hat here. This is like a caret. And I'll explain why in a second. Y hat equals 25.333 plus 7.6464x. Okay? We pronounce that y hat. And that means it's the predicted y. So that's the predicted value of what y would be. It's not going to be the actual number because obviously things will fluctuate, but that's just the predicted number there. Now, in terms of interpreting this, a lot of times I like writing the equations in terms of English instead of just math. And so you could say this, y is my distance, so I'm going to call this distance hat. And that's going to equal 25.333 plus 7.464. And what's x? Rubber bands. Okay? So now if I want to use that regression line to predict what they came up with for number 5, what we would end up doing here is this. We would say, okay, 25.33 plus my 7.464 times 5 rubber bands. Why? Because that's what x is. So when I do all that math, I type it in, my predicted distance is going to end up equaling 62.653 centimeters. Pardon me one second. One group of members later found the measurement for 5 rubber bands was 64 centimeters. So was the prediction for number 2 high or too low? How far off? So in this case here, we would say, all right, so 64, the prediction, was the prediction too high or too low? The prediction was too low. How much? So we had 64 was the actual minus my prediction of 62. Wow, that's an ugly minus sign. 653, so that's going to equal 1.347 centimeters. And so we would say it was 1.347 centimeters too low. Because again, oh, wait, we're not supposed to use pronouns all the time. What was it? Okay, that's the predicted distance. Now, this difference between what actually happens and what's predicted to happen is called a residual. It's not like the money that you get if you're a music artist or a television person. You get checks from reruns and stuff. So residual equals the actual minus the predicted. Why is that important? Because that actually helps shape that regression line that we end up having. Okay, so predict the distance that Barbie would travel if we use 20 rubber bands. Would you trust this prediction more or less than the one that you made in number 2? Okay, so here, what we're saying is this. Here we've got a prediction. This prediction here was within from here to here. Then I'm asking you to make the jump. What happens over here? Oops, you can't see it over here if we get up to 20. So the prediction would be 25.33 plus 7.464. Wow, that is just bad writing. So when we do all of that, type it into your calculator, let the gerbils do their work. You get 174.613 centimeters. Just realized I forgot the bleed through. Oh, not too bad. So the question is, do you trust this more or less? Now think about it. We were this far off when we were within data here. Now we're going further out. And so it turns out that we're going to trust this less because it is further away from the x-axis. Okay, this is called extrapolation. Okay, and that extrapolation is generally you want to try to keep it within the data that you have yourself over here. Anything outside of that is going to be kind of iffy. So what is the y-intercept of the equation of the regression line? What does it mean? Now this is getting back to some stuff we did back in algebra, so hopefully you will remember some of this. So we've got the point, the y-intercept is 0, 25.333. So that means when we use 0 rubber bands, what type of distance is this? Predicted distance, yeah. Of travel is how much? 25.333 centimeters. So notice here, okay, this is x, there's y. What's the slope of this equation of the regression line? Oh my goodness, more algebra one. Well, your slope is which one? The slope's going to be the number out here in front of the x, so that means it's going to be this one right here, the 7.464. So, now remember, slope is what? Change in y over change in x. And so, what are we measuring y in? We're measuring y in centimeters. We're changing x in rubber bands. So if you have this set up, that's, you know, and then you put the variables in, that kind of helps you with that. So 7.464, so we're going to say when we add, because what are we controlling? We're controlling the x value. So when we add 1 rubber band, the predicted distance traveled increases by how much? By 7.464 centimeters. So again, notice, here's my slope. This over here, x increased by 1. Okay? So again, that would be the type of thing that you'd be working through in your groups. So go ahead, link below will get you to the formal part of this, where we're going to say exactly how you're required, should refer to all of this. See you in a second.